everybody. Thank you for joining today's session in the Changes webinar series. Today's topic is called From Now to Next, Real-Time Data Integration for Instant Insights. Today's session is all about how organizations can unify cloud and on-prem data in real time to drive faster and smarter decisions. We're thrilled to have Rathnikanan Rajagopal leading this session. He is a seasoned expert in enterprise data integration and a key mind behind dataZap, our powerful integration engine. He'll share practical insights, real-world use cases, and most importantly, walk you through a live demo to show you how it all works in action. So let's get into this. If you have any questions, feel free to drop them in the chat and let's dive in. Ratnikanan, over to you.
Thank you, Mahek. Hello, everyone. Welcome to Changes 2025 webinar series. Today's session is from now to next, real-time data integration for instant insights. So in today's session, we'll explore why real-time data integration is a necessity today and how Changes dataZap helps enterprises to achieve it. This session includes both insights and live demos, so stay tuned. Before we deep dive into the session, let's start with why this topic matters. In today's world, yesterday's data is already outdated. Think about a fraud detection or an inventory update, a patient care. Waiting even an hour can be too late. So enterprises believe real-time data is critical to staying competitive. Real-time integration is not just a nice to have anymore, it is essential. So for those new to Change, this is a quick introduction. We've been helping enterprises for data migration and data integration for over 2 decades. Our smart data platform includes solutions for data integration, data migration, data quality, master data management, data governance, and catalog, custom application building, and so on. Today we will focus on dataZap, our integration and migration platform trusted by Fortune 500 companies across industries. Traditionally, companies used batch ETL, data moved overnight or on schedules, but that model no longer supports business needs. Today, the shift is towards streaming the real-time pipelines. Instead of waiting hours, we are tracking seconds. So enabling decisions in the moment. So that's a leap from now to next. So at a high level, the real-time integration pipelines connect 3 things. One is data sources and target systems and the integration engine. Your sources could be any applications or IoT devices or cloud platforms, and your target could be your enterprise data warehouse, BI dashboard, or any applications or analytics. And you have the data integration engine, which is dataZap. And the key characteristics is near zero latency, and it should be scalable, and it's fault tolerance. What are the common challenges that we foresee in while building a real-time data integration? So the latency in the legacy systems. So many enterprises face latency due to old architectures, systems are fragmented, and data quality and trust issues. And security compliance cannot be compromised. Here are some real world use cases. So in one of the university in Midwest, so they had a scenario like they wanted to interface SAP ECC and Procore. So all their financial data resides in SAP ECC, whereas the project management data they use Procore. So the financial data needs to be moved into Procore, and similarly, all the change events from Procore to be interfaced into SAP ECC. So for that, we leveraged Procore's webhook APIs and BAPIs from SAP. So that's how we're able to build a real-time data integration between these systems. In a global retailing company where they produce and sells lenses, there were many legacy point of sale systems sitting in multiple locations, around 70 plus locations. Those needs to be interfaced into Oracle EBS for live inventory and demand sync. So again, we used here Oracle EBS APIs. We leveraged it and then interfaced all the locations with unified Oracle EBS. And then in a construction company, where all the masters were in Oracle EBS, and they used Procore for project management. So the master data need to be interfaced into Oracle EBS, sorry, from Oracle EBS to Procore, and then commitments and change events to be moved from Procore to EBS. So again, we leveraged webhook APIs from Procore and used Oracle EBS APIs for building the real-time integration here. And then in a global manufacturing company, where they wanted to build a supply chain planning system as a standalone system, but for that they need to get demand and supply data from Oracle EBS. And in this integration, there are multiple systems involved: Oracle EBS, Salesforce, and few more legacy systems. So through which we are able to build a near real-time data integration. So the business benefits what we are getting after building a uh, real-time data integration is you'll be able to act faster and take immediate decisions. So you'll be able to stay ahead in the market, and it boosts your efficiency and out of the automated workflows, and it increases your confidence by having the real-time insight. There are multiple methods in building the real-time data integration. Let's see some approaches. The data change data capture. So it tracks all the database inserts, updates, and deletes at the database level and streams those changes in real time to the downstream systems. And then message queues and event streaming, where systems like Kafka or any cloud native systems to push events instantly across applications. And then we have API based integration, where real time data exchanges via REST API from one application to another. And then ETL with micro batching, where we'll have real-time pipelines using smaller batch intervals for continuous updates. Like we can schedule a job to run every 1 minute or 2 minutes. Based on that, we'll be able to achieve a small batch interval integration. And then next is the webhook event notification, which is the most commonly used real-time data integration in the modern cloud applications world, where systems automatically notify the downstream applications whenever the event occurs. And then the next approach is direct database replication, where the data mirrors across systems instantly for high availability and real-time analytics. So this is where changes dataZap comes in. It provides the enterprise grade data integration engine, which helps for seamless real-time streaming, and it can help you to build real-time integration between cloud and on-premise systems with its 200 plus pre-built connectors and thousands of pre-built templates for the applications like Oracle EBS, Oracle Fusion Cloud, SAP, Dynamics, JD Edwards, and so on. The key capabilities of the engine is it provides you the high performance pipelines by which you'll be able to interface millions of records, and it's hybrid connectivity, which helps you to connect to any cloud, SaaS applications, or legacy on-premise systems. And it comes with all the data security and traceability, and main thing is flexible. So you'll be able to build a real-time integration with just configurations without any coding. To maximize real-time success, we need to design the pipelines for scalability so that the additional systems can be easily scalable and ensure the governance and traceability. While building the systems, and we need to monitor proactively whether all the data has been interfaced correctly between the systems, and built for hybrid environments where cloud and on-premise coexist. So these practices ensure both performance and trust. Now let's get into the action. The scenario which we are going to build is we are going to have our source as Salesforce, where we'll be creating an account. Um, so once we create an account, it's going to be interfaced into Snowflake. So that's our final target. But in between, we have kept Kafka as a streaming platform. So we can build an integration between Salesforce and Snowflake real time just by using a single data pipeline. But just to showcase you the dataZap's capability, so I have kept it as a two data pipeline concept. So in the first data pipeline, which is going to pull data from Salesforce account and then publish it into Kafka topic. And then the second pipeline is going to listen to the Kafka topic. And as soon as the data arrives, it's going to consume it and push into Snowflake. And finally, we'll be showing the data in a BI dashboard um, where we can see whether the data has been interfaced or not. Let's get into the system. I'm logging into the Changes platform demo environment. So this is dataZap, your data integration engine. So before building a data integration, let's start with establishing the connection to the source and target systems. Let me go to the connection screen. So these are the endpoints that our platform supports. Since our source is going to be Salesforce, so this is how we establish connectivity between uh, Salesforce. Like, so we use session ID as an authentication type here. It also supports OAuth 2 as well. And then we need to provide the username and password. That's it. Your connection is ready. Salesforce connection is ready. And then we have a Kafka connection. So this is the Kafka connection that we have configured. And then I'm going to show you the Snowflake connection. It's part of big data. So this is the data Snowflake connection that we are going to use for today's demonstration. So we have used DB credential, user credential authentication type, and we have provided username and password. We have given the values which you are going to use and the database and schema name. Okay, now let's get started. So the connections are ready. To configure a pipeline, um, we need to have two. One is for extracting the data from the source, and then the loader to push the data into the target system. First, let's define a data object to extract data from the source. So this is the connection I'm going to use. I'll defining the name for the data object, account-3. I'm not going to stage the data. Save it. So after saving this, we need to provide a Salesforce information. Going to the next one, where I'm going to have selected SOAP API type. So where we have a bulk API option as well. Since it's a real-time integration, the mostly the data will be moved record by record. So we'll continue to use the SOAP option. So I'm selecting the account object. Once I select the account object, all the columns of those account of the account object will be shown here. I'm selecting all the columns. Save it. Now the extraction object is ready. In addition to that, I'm going to configure a runtime input because from the Salesforce, I'm going to receive account ID as an input. I'm selecting value as mandatory. Okay. So why am I adding this account ID as an runtime parameter is You can see here. So in the Salesforce, that's the first event. I'm going to create an account in Salesforce, and then I have configured a trigger in Salesforce to send the newly created account ID to the API. In the changes data pipeline is going to receive the account ID as an input, and then it's going to fetch all other columns of the account ID from the Salesforce and publish that data as a JSON into Kafka. Okay, save the data flow, data object, compiled it. Now I'm going to create a loader. So this loader is going to produce data into Kafka topic. This is the connection I'm going to use. I'm entering Kafka account -3 as my loader name. Just save it. And the next step, I'll be entering the Kafka topic details. Okay, the mode of reading I'm going to use is data mode, and topic I'm going to listen is BCG, and the data format I'm going to use is JSON. So this is the JSON. So once I upload the JSON, all the columns from the JSON will be listed here. Okay, so these are the keys available in the JSON. I'm selecting all the columns and adding it to a data set called account. Save it. My loader is ready. So I have created a data object to extract data from Salesforce using the account ID, and then I have created a Kafka loader to produce the received account data as a JSON into a topic called BCG. Okay. Now I'm going to create a data pipeline. So to create a pipeline, I need to configure the data object. Let me select dev as my sprint here. Standard demo. This is my data mart. SFDC account to Kafka 3. So here I am going to select my source. My source is data object, which I created now recently. SFDC account -3. This is the one I created. And I'm selecting my target as my loader. Kafka account -3. This is my loader. Now I'm going to map these two. Now it's been mapped. Now I'm going to do the column level mapping. So I'm going to map all the columns which are having common names between the two systems by using the matching names method. Just click on the map button. All the columns got mapped. Saved it. Close. I compiled it. Now my data pipeline is ready. So what I'm going to do is, so this data object will receive account ID as an input, and then it will pull all the columns of the account ID from the Salesforce and push it to the Kafka loader. It's going to publish that data as a JSON into Kafka topic. Okay. Now what I'm going to do is, since it's a real-time integration, now I need to publish this data flow as a REST API. I open the publisher option. So publisher is the one which helps to publish any object as a API for any real-time data integration. So the object type I'm going to select is data flow because I have created data pipeline. Need to define the pipeline name, SFDC account to Kafka 3. So this is my publisher name, dev SFDC Kafka. So this is the data pipeline which we created. I'm going to publish it as a REST API, and both the payload, request payload and the response payload I want is in a JSON format. Save it. Now publisher is saved. Now I'm going to publish it. So once I publish, we'll get the REST API. You got it. So this is the REST API URL, and you can click on this button to get the request payload. And this REST API URL will be configured in the Salesforce as a trigger. Okay, so that whenever I create a new account in Salesforce, it is going to call this REST API and pass that account ID as an input to the REST API. Okay, so that's a triggering point. Now what we have done is we have created one data pipeline. Now I'm going to create the next pipeline. Okay, so the first pipeline is to pull data from the Salesforce and publish it as a JSON into a Kafka topic. And the second pipeline, I'm going to create to listen to the Kafka topic and receive the data and push into Snowflake table. Now I'm going to create a data object which is going to listen to Kafka topic. This is a Kafka connection. I'm going to listen. Kafka account -3. That's it. Save it. Go to the next step where you need to define the topic name which you are going to listen. BCG is the topic name I'm going to listen. The data format is JSON. Let me upload the sample JSON file. So this is the JSON format I'm going to receive in the Kafka topic. So once I upload it, all the columns are listed here. I select all the columns, save it, compile the data object. Now my Kafka listener is ready. Now I'm going to create a loader to load the data into Snowflake. This is the Snowflake connection. Snowflake account -3 is the name I'm going to use. And the type is table. So it's just a table insert. Save it. Go to the next step where I need to select the table in which I'm going to load my data. This is the table which is in my EDM bronze layer. If I've got all the columns, it all selected by default and added to the data set. Just save it and compile. Now my extraction object and loader is ready. Now I'm going to create a data pipeline to connect these two. Kafka account to Snowflake -3. So in this data pipeline, I'm going to select the data object which was listening to the Kafka topic. uh, account 3 is my data object name. Selected it, and my target is going to be my snowflake loader. This is my loader. I'm going to connect these two. Now I'm going to map the columns. So columns which are having common name got mapped automatically. Save it. Compile. My data pipeline is ready. Here you can see a button called Start Listener. Why it is coming is because my source object is Kafka, which is which has to listen to a topic. So that's why we are seeing this option. So if I click this Start Listener, what it's going to do is the data object is going to listen to the topic which I defined in this data object, which is BCG. So it will be listening to the topic continuously, and whenever the data published in the topic, it's going to consume the data and pass the JSON and push into the Snowflake tables. Okay. Now, so we already published the first data pipelines as an REST API, right? So configuring that data pipeline in Salesforce may take some time. So I already configured it in the Salesforce. Now I'm going to enter a new account in my Salesforce account. Okay, before that, let me show you the BA dashboard where I'm going to receive the, so once I receive the data in the Snowflake, I have a BA dashboard which is pointing to this Snowflake table, so that we don't need to see the table whether we got the data or not. In a real time, we'll be able to see it in the dashboard. So this is the Snowflake accounts report. Okay, so totally there are 81 accounts available in the Salesforce, and their statuses are shown in this chart. And then the accounts are shown by its payment terms, and these are all the accounts available in the Salesforce. Meaning, so all these 81 accounts which are created in Salesforce already got interfaced into my Snowflake tables. From there only we are seeing this dashboard. Okay, now I'm going to create a new account in Salesforce. So before I create, let me reiterate. So once I create an account in Salesforce, it is going to, I already configured a trigger, okay, and the trigger is going to send the account ID of the newly created account to the first data pipeline which I created, okay, and this data pipeline is going to receive the account ID, and then it's going to pull all relevant information from Salesforce using the account ID as an input, and then it's going to send the data to the Kafka loader, which will convert the data as a JSON and produce that JSON into a Kafka topic. After that, the second data pipeline listening to the Kafka topic. Once the data produces in the topic, it is going to consume the data and push into and pass the JSON data and then push into Snowflake table. And my dashboard is based on the Snowflake table. So that's why once the integration is done, I'll be seeing the latest data in my dashboard here. Let me create a new account. Genesis Corp. Genesis. My billing address 325 South. Street, Grand Ledge, state is Michigan, food applied 37, billing country is USA. I'm selecting my payment term as 30, flight term as 6 months, type organization, currency type USD, status open. Now I'm going to save this. Once I save this, this new account will be immediately available in our dashboard. Saved it. Now Changes Corp account is being created in Salesforce. By now the integration would have been triggered. Let me refresh my dashboard. So already we have 81 accounts. We got it. So one account has been added. Let's see the data which we created in Salesforce. Yes, this is the one, the last one. Changes Corp is the account we created in Salesforce, and it gets interfaced into this dashboard through Kafka and Snowflake. We got it right now. So let me reiterate once again what we did. So we created one data pipeline and publish that data pipeline as a REST API. And that REST API has been configured in Salesforce as a trigger. But this part I didn't show in this demonstration because it's a lot of work to do. So that's why I didn't show that part alone. Okay, rest all the same. So the first data pipeline, its REST API has been configured in the Salesforce as a trigger, so that whenever a new account is created in Salesforce, it's going to send that account ID as an input to this REST API of the data pipeline. After receiving the account ID, it is going to extract all other columns information from Salesforce and then push into a Kafka loader, where the Kafka loader converts that data as a JSON and produce that data into Kafka topic. Once the data being produced into Kafka topic, there's the second pipeline which is listening to the Kafka topic. It consumes the data, accounts data, and parse the JSON and convert it to in a format to insert into Snowflake tables, and it pushes. So this is how we can create a real-time integration between applications. So here we have covered two types of real-time integration. One is streaming based, and another is webhook or trigger based or event based real-time integration. So this part is all about webhook based integration, and the second pipeline which is listening to Kafka topic is based on streaming based pipeline. So this is how we'll be able to configure real-time integration in dataZap. So key takeaways, we need to act faster and do not rely on the yesterday's data. Stay connected, integrate hybrid systems seamlessly and with accuracy, security, and traceability, so that you can trust your data. And dataZap grows with your enterprise needs. You can scale confidently. Thank you for listening to this webinar. Now it's time for Q&A.
Well, thank you so much, Ratnikanan, for the insightful and engaging presentation and the in-depth demo. It brings out, I think, a lot of clarity for all our attendees and us as well. So yes, like Ratnikanan said, we'll now move on to the Q&A. Feel free to drop your questions. We've already received some, so let's start with that. Um, the first question that we have is, what's the difference between real time and near real time integration?
Very good question. So real time means changes are captured and delivered in milliseconds. We saw it, right? So as soon as we created an account in Salesforce, immediately it's available in your dashboard. right? So that's real-time integration. Near real-time integration is basically done with the help of schedulers, which can fetch the data in micro batches, let's say in a 2 minutes or 1 minutes time frame. So that's what is near real-time integration.
Um, Next question is, how does Chance's dataZap handle hybrid environments, which is cloud and on-prem?
Okay, so dataZap has 200 plus pre-built connectors for both cloud and on-premise systems. So through which we'll be able to connect any system, like let's say it can connect to list of big data systems. It can connect to systems like enterprise storage systems like Google Drive, SharePoint, or it can connect to any relational database systems. And we have pre-built connectors for all the um, enterprise cloud applications like Oracle Fusion Cloud, SAP S4HANA, Salesforce, and it goes on. So through which we'll be able to handle both on-premise, cloud, and all the hybrid environments.
Um, the next question is, what about data accuracy and security during real-time transfers?
Okay, so here the accuracy is ensured with the help of data validation. Okay, so our loader adapter has a unique feature called data validation, which validates the data before it moves into the target system. Okay, and security is built in with encryption at both in motion and at rest. So the platform comes with role-based access and audit trials. So governance is not compromised.
Next question is, how scalable is dataZap for enterprise workloads?
Okay, so dataZap is built for scalability. Let's say if you're a small or medium enterprise, you can you can have single node application. Or it's for, if it's for a large enterprises, we can scale the integration nodes into multiple VMs, so that we'll be able to handle thousands of daily events or millions of records. So it's a distributed architecture. It ensures performance without any bottlenecks.
Yes, thank you. We have another question, which is it possible to create AI agents for DataZap or integrate DataZap with Flowise, UiPath, Jenkins, Na10?
It's an Jenkins. See, that's for building our solution, right? So here we are talking about any real-time data integration between applications, okay? And it has capability to connect to AI agents, like it has connected to OpenAI, so or else Gemini. We have the connectors through which we'll be able to connect those systems and make use of those AI features in our systems for data mapping. For example, when we create a data pipeline, we need to connect the source and target systems. Maybe when we connect two different applications where the column names are not going to be the same. Okay, so that's a challenge, and functional people's help is required to map those columns. So that's where we leverage a agents help to get the available data from the web to build the mapping automatically.
Well, perfect. That was our last question for the day. If our attendees have any more questions, feel free to write to us or reach out to us. You can also go onto our website and schedule a demo if you are interested in any of these solutions. But for today, thank you for joining us. And a big thank you to Ratnikanan for the insights and the demo. We hope everybody found this session very valuable and maybe gathered some key resources for their next project. So, for till next time, we will say goodbye and hope to see you in the future webinars. Thank you and have a good day, everyone.